Welcome back. When I was a small child, when my parents used to shout at me, I used to feel so sad. I don't understand why these people shout at me for no reason. Okay, maybe they have their own reasons. And then I used to think that if I have a magic wand, maybe I would say abracadabra, and then these big people become small children like me, and then maybe they would understand me better. Did you ever think like that about your parents? Today, we are going to learn about a magic wand that is going to transform big numbers into small numbers. Okay, for example, from 0, the single number digits like 1 to 9, these are the ones like children, okay? They are the first numbers that came from 0. And now all these 10, 20, 1 million, 1 billion, these are like big numbers. These are like your parents, big people. Now, using a magic wand called digit sum, we will see how to transform these big numbers into single digit numbers. Suppose we have a number 17. To make this into a single digit number, okay, we call it digit sum. What we need to do is, we simply need to add up these digits 1 and 7. So, 1 plus 7 is 8. That's all. So, 8 is the digit sum for 17. Okay. Say for example, take a little bigger number. Say 123. What is the digit sum? You just need to add up all these 3 digits. 1 plus 2 plus 3. It's a 6. 6 is the digit sum. You will see there are so many advantages if we learn this digit sum. Now pause the video and find the digit sum for these 3 numbers. These are the answers for you. Did you get them right? Suppose we have a number 19. What is the digit sum for 19? We have to say 1 plus 9 is 10. Oh, but this is a 10. This is still a 2-digit number. We want the final answer to be a single-digit number. So what we should do? Yes, we have to take the digit sum of 10 again. So 1 plus 0 is a 1. Okay, this 1 is the digit sum for 19. As simple as that. Now, what is the digit sum for 39? Okay, so 3 plus 9 is a 12. Okay, we take the digit sum of 12 again. So this will be 1 plus 2 is a 3. Now pause the video and try to find the digit sums for these numbers. Here are the answers for you. Did you get them right? We have seen how the numbers in the system flow in cycles of 10. We have represented all those numbers over a 10-point circle. Okay? Now we will see a funny thing. How the digit sums of all the numbers will behave. Okay? Now, here I have given the digit sums of numbers from 1 to 20. Okay? So, digit sum of 1 is a 1, 2 is a 2 like this. These are single digit numbers. And then from 10 onwards, 10 to 20, I gave the digit sums here. Okay? Now pause the video and see for any patterns here. Did you get it? Yes. Digit sums of all the numbers will flow in a cycle of 9. So if you see from 1 to 9 and then 1 to 9 and so on. So we can represent the digit sums of all the numbers, integers, over a cycle of 9 points. Okay, just like we have a 10-point circle, now we will see a 9-point circle. Now we have a 9-point circle over which we can represent all the numbers from 1 to infinity. Okay, here I have represented numbers from 1 to 20 for now. Okay, so here we see from 1 to 9 the numbers are here, and then 10 to 18, and then they go on in cycles of 9 points. Now, from digit sum point of view, okay, you have to find the patterns. Pause the video and see any beautiful patterns in this circle. Yes, this is like a tree with 9 branches. Okay, this is one branch, this is one branch, this is one branch, and so on. For each branch of numbers, the digit sum is the same. Okay, so for example, we have a branch here, 1, 10, 19, and so on. For all these numbers, the digit sum is a 1. That's all. For all the numbers in this branch, digit sum is 2. Okay. For example, there is a number 24. On which branch will 24 come? 24, digit sum is a 6. So, it will come here. You will have a 24. Suppose you have a number 132. Where will it come? 1 plus 3 plus 2 is a 6. Hey, it will also come somewhere here. 1, 3, 2 number will be coming here. Okay, now you see any other pattern here. Did you get it? If you add a 9 to a number, its digit sum will not change. For example, we have a number 11 here. You add a 9, we reach a 20. Digit sum is same, because from 9, we went around the 9-point circle once and arrived at the same branch. As simple as that. Okay, now the opposite is also true. What is that? You can pause the video and think about it. From any number, if you subtract a 9, its digit sum will not change. As simple as that. From 11, you subtract a 9. You arrive at 2. Digit sum remains the same. As simple as that. Okay, there is a little bit funny thing here. Okay, I'll see. Suppose we have an 18. Okay, if you subtract a 9, you arrive at 9. Digit sum of 18 or 9 is same. Okay, now you subtract one more 9 from 9, you get a 0. Oh, it's a 0 here. What is the point here? Whether the digit sum of a number is 9 or a 0, it means the same. We have seen that adding a 9 to a number does not change its digit sum. Say for example, we have a number 4. So what is the digit sum for 4? It's a 4. Suppose we have a number 49. What is the digit sum for 49? 4 plus 9 is a 13. Okay. And then 1 plus 3 is a 4. Oh, do we need to do all this? No. We know this 9 does not contribute to the digit sum, so we can simply cast away this 9. The answer is a 4. Oh, okay. So if I ask you, what is the digit sum for 4999? You can simply cast away these 9s. The digit sum for this number is simply a 4. Now pause the video and find the digit sums of these numbers using the technique we just learned. You can simply cast away the 9s. Here are the answers for you. Did you get them right? Now find the digit sums for these numbers using the technique of casting away 9s. Oh, there are no 9s here. How can we cast them away? Can you take a pause and think about it? Yes. You can find the digits that add up to a 9 and simply cast them away. Say, for example, here, 2 and 7 add up to a 9, so we can simply cast them away. Okay, and what the remaining is 4 and 1. Okay, 4 plus 1 is a 5. Okay, here you can see any combinations of digits that add up to a 9 and simply cast them away. 5, 3, and 1 add up to 9, so we take them away. 0 doesn't contribute to digit sum, so here the answer is a 2. Now pause the video and find the digit sums for these numbers. Here are the answers for you. Did you get them right? In the last one, we can cast away the 9 here, and then any other 9s here? Oh yeah, 8 and 1 is a 9, we cast it out. Oh okay, 2 and 7 also add up to 9, so we can cast them away, and we have 3 and 6. Okay, you can say 3 plus 6 is 9 is the digit sum, or simply you can cast away a 9, and what is remaining? It's a 0. Shall I ask you a puzzle? There is a 2-digit number whose digit sum is 8 and both digits are same. Pause the video and think about it. What is that number? So it's a 44. 4 and 4, digit sum is 8. Another puzzle. There is a 2-digit number whose digit sum is 9 and the first digit is double that of the second digit. Pause the video and think about it. Yes, it's a 63. 6 is double of 3. Now pause the video and give me some 2-digit numbers and 3-digit numbers that have a digit sum of 3. Okay. You can write a 12 here. Okay, how about here? You can write, say, 21. That's very easy. And here what you can write, say, 30. Oh, okay. Give me a 3-digit number that has a digit sum of 3. You can write in so many ways. I know. What did you write? Say, for example, you can say 3, 0, and you can put a 0 or put a 9 here. Doesn't matter. The digit sum is 3. Now we go a little tougher. Give me a 2-digit number that has a digit sum of 5 and both digits are same. You can't say 2 plus 2. No, it's a 4. 3 plus 3, it's a 6. Oh. But go back to your 9-point circle for a beautiful hint. Did you get it? Yeah, if you see the 9-point circle, okay, what are the numbers in the 5 branch? That means all have the same digit sum. 5, digit sum is 5. What is the next one? 14 is the one that has a digit sum of 5. Okay, 14 you can split into 2 numbers. It's a 7 and 7. Okay, now 77 has a digit sum of 5. As simple as that. I know you want to do lots of puzzles. You can do some beautiful puzzles given in the homework after the class. Now we will see some excellent uses of digit sum. Digit sum can be used to check the answers of your additions, multiplications, problems, and so on. Okay, we'll see a funny example here. Suppose you have an addition problem 32 plus 12. Okay, you know the answer, it's a 44. Okay, so we will see if this is right or not, if the answer is right or not using digit sums. Okay, what is the digit sum for 32? It's a 5. Okay, what is the digit sum for 12? It's a 3. Okay, what is the digit sum for 44? It's a 8. Okay, 5 plus 3 is a 8. Okay, that gives you a hint that, oh, okay, this is the right answer. We see a bigger addition problem and we will check the answer using digit sums. Okay, now we will do the addition. Okay, we can start from right. 5 plus 8 is a 13. So 1 is a carry. Okay, 1 comes here and 3 comes down in the answer. And this is a 7 and this is a 5. Now find the digit sums of all these numbers. What is the digit sum for 3, 6, 5? Okay, 6 and 3 add up to a 9, so we can cast away. And digit sum here is a 5. And how about here? Okay, we know 2 plus 8 is a 10. 10 means, again, 1 plus 0 is a 1 is the digit sum. And how about the digit sum for 5, 7, 3? It's a 15. 15 means 1 plus 5, it's a 6. Okay, 5 plus 1 is also giving 6. Okay, then this answer must be correct. Now pause the video and do this addition by yourself and find the digit sums and confirm the answer is correct. Did you get the answer? You could see 5 plus 7 is a 12. The digit sum is 3. Okay, so 3 is the answer for this way as well as this way. Now somebody did an addition problem like this and we have to check whether it is right or wrong using digit sums. Okay, let's try this. Okay, what is the digit sum for 2, 7, 9? Okay, 9 is gone. 2 plus 7 is a 9 here. And here the digit sum is a 4. Okay, 9 plus 4 digit sum is a 13. 13 means a 4 again. Okay. And then how about this answer's digit sum? Okay, 9 you can cast away. Oh, okay. So digit sum is 4. Okay, that means this must be correct. Oh, wait. If you do the addition by yourself, this answer is not right. Pause the video and think about it. The correct answer for this addition problem is actually a 400. Okay, that guy made a mistake here. Okay, we have to keep in mind that digit sum check usually works, but not all the time. Okay? We will see a multiplication problem and check the answer with digit sums. Okay? 38 times 3. Okay, how to do this? Multiplication. In Vedic way of multiplication, we will have probably in the next class. That is going to be fantastic. But now we will stick to the usual way of multiplication. Okay, if you want to do a multiply with a number, what do you have to do? 3 times 8 is a 24. Okay, 2 is a carry and 4 we put down in the answer. 3 times 3 plus the carry. Okay, 9 plus 2 is a 11. The answer is a 114. Okay, now what is the digit sum for 38? 8, 3 plus 8, 11. That means 1 plus 1 is a 2. Okay, digit sum for 3 is a 3. Okay, 2 times 3 is a 6. 114, the digit sum is 6. Okay, that means this answer is probably correct. Now pause the video and do these multiplications by yourself and check your answer with digit sum check. Here are the answers for you. You can see 8 times 4 is 32. Okay, 32 digit sum is 5 here. Okay, here the multiplication of digit sums. 5 times 6 gives a 30, whose digit sum is 3. Okay, if you check, these are probably correct answers. Now we will do a funny thing. This is page 18 of your workbook. Open it. In the last class, we have filled in multiplication tables. Okay, the table here, the upper one, contains your multiplication table from 1 times 1 to 9 times 9. And this table below contains the digit sums of all these multiplication table numbers. Okay, now you can see this first row of numbers correspond to the digit sums of your multiplication table of 1. Okay, like that. Suppose you have this last row, this contains the digit sums of all your multiplication table of 9. Okay, now pause the video and find any interesting patterns in this table called the Vedic square. Now you open page 20 of the workbook. Okay, here we have 9 Vedic squares. For each Vedic square, you take a color pencil and color one number. For example, in this Vedic square, you only color the digits 1. Okay, in this Vedic square, you color all the 2's like that. Okay, and see if you find any patterns. In the last class, we learned how to do multiplication table of 9 using fingers. Now, we will see how to do multiplication from 5 times 5 to 9 times 9 using your hands. Okay, this is a completely different procedure. Okay, are you ready to learn this? Now we will learn multiplication from 5 times 5 to 9 times 9 using your hands. We will choose one number from your left hand, one number from your right hand. For that, we assign a number to each finger on both hands. Okay, now you move thumb and say 5. Your thumb is digit 5. 6, 7, 8, 9. If I ask you what is finger 7 on your left hand, you have to move this finger. If I ask you what is finger 8 on your right hand, you have to move this finger. Okay, now we do multiplication of say 7 times 8. Okay, so we have to choose 7 from left hand, 8 from right hand, say. Okay, 7 from your left hand is this. What you do now is you put all the fingers from 7 and below it, that is 8 and 9, to sleep like this. On your right, which one is 8? This one. Okay, now you put the finger 8 and the fingers below it. Okay, now we have a 9 also, sleeping on the right. Now move the hands closer. Now you can see there are some fingers standing and some fingers sleeping. Okay, now you count all the fingers standing on both hands together. Okay, there are, how many are there? Oh, there are 5 fingers standing. These are the tens in your answer. Okay, that means it's a 50. Okay, now how many fingers are sleeping on the left side? 3. How many fingers are sleeping on the right side? 2. You multiply 3 and 2, you get a 6. These are the units in your answer. So the answer is a 50 plus 6, it's a 56. That's all. Now pause the video and try some multiplications by yourself using the hand multiplication method. You can do anything from 5 times 5 to 9 times 9. In Vedic mathematics, it is enough if you remember multiplication tables up to 5th table. You can do any multiplication just like that so easily, as you will see in the next classes. That's all for today. Thank you.